Machines have begun solving problems they were never taught to handle, leaving researchers stunned. Recent breakthroughs reveal AI systems that evolve independently, improving themselves without human input. Could this be the path to unimaginable progress or unforeseen consequences? The era of self-training. AI has arrived, and it's time to dive into it. What is AI superintelligence? Artificial intelligence has already made leaps and bounds, but not all AI is created equal. To understand superintelligence, it's important to first distinguish it from narrow AI and general AI. Narrow AI is designed to perform a specific task, like recommending movies, detecting fraud, or playing chess. Think of it as a highly skilled specialist, incredible at one thing but clueless about others. General AI, on the other hand, represents a system capable of understanding and performing any intellectual task a human can do. It's the hypothetical jack-of-all-trades AI. But superintelligence? That takes it a step further. Superintelligence refers to an AI system that surpasses human intelligence in every conceivable way. Reasoning, creativity, problem-solving, and even emotional intelligence. It's not just a better thinker. It's an entirely new level of intelligence, capable of solving problems humans haven't even dreamed of tackling. To make this easier to understand, imagine a student who learns basic math, then teaches themselves algebra, calculus, and quantum physics without any further instruction. Now imagine they go beyond even the most advanced human understanding of the universe. That's the leap we're talking about when it comes to superintelligence. It's the difference between following instructions and rewriting the instruction manual altogether. Why are researchers baffled? The idea of AI that can teach itself has always been on the horizon, but recent breakthroughs have brought this concept into reality faster than expected. One particularly groundbreaking example is RStar Math, a self-improving AI system that has outperformed some of the largest models in specific tasks like math reasoning. What's baffling researchers is not just the performance of these systems, but the how behind it. Take the phenomenon of emergent behavior in AI, for instance. In systems like AlphaZero, AI has developed strategies and approaches to problems that it was never explicitly taught. AlphaZero, a system built by DeepMind, learned to play chess, Go, and shogi at a superhuman level without being taught the rules. Instead, it taught itself through trial and error, discovering strategies that stunned even the world's greatest human players. This challenges traditional programming principles, where every behavior is coded in by humans. In these new AI systems, the machine essentially writes its own playbook. It's as if a robot was programmed to walk but suddenly decided to sprint, climb, and perform backflips, all without being told to do so. What's even more surprising is the rate at which these systems are evolving. Unlike human intelligence, which grows gradually, self-improving AI can progress exponentially, refining itself with every iteration. It's this rapid, unpredictable growth that has researchers both excited and deeply concerned. How does AI self-train? To understand how AI trains itself, think of it as a curious child learning to ride a bike. At first, it tried different techniques, balancing on one foot, wobbling left and right. With each fall, the child adjusts its strategy until it can ride smoothly. This process of trial, error, and adjustment is at the heart of how self-training AI works. In technical terms, this involves concepts like reinforcement learning and unsupervised learning. Reinforcement learning is like playing a video game. The AI takes an action, observes the outcome, and is rewarded or penalized based on whether the action was successful. Over time, it learns to maximize rewards by refining its actions. The self-training process can be broken down into 4 key steps. Data collection. AI begins by gathering information from its surroundings or input data, just like a student carefully taking notes during a class. This step is crucial because the quality and depth of the collected data determine how much the AI can understand and learn from the world around it. Pattern recognition. Once the data is collected, the AI looks for patterns, relationships, or rules within it. Think of this as the moment a student realizes that 2 + 2 always equals 4. It identifies consistent trends and uses them to build a foundation for its knowledge and problem solving. Hypothesis generation. Based on the patterns it finds, the AI forms educated guesses or strategies to solve specific problems. This is like a student predicting what might be on a test after noticing what the teacher focuses on. These guesses become the starting points for future learning. Feedback loops. The AI tests its guesses or strategies to see if they work, learns from any mistakes, and adjusts accordingly. This trial and error process, much like a student refining answers after getting them wrong, ensures the AI continually improves and gets closer to the best possible solutions. Real-world systems like GPT models and AlphaZero are excellent examples of self-training in action. GPT models, for instance, use massive datasets to generate human-like text, but can also refine their understanding through reinforcement. AlphaZero took this a step further by mastering games without pre-existing human strategies, relying solely on its ability to learn from its own experience. When did signs of self-training AI first appear? The journey towards self-training AI has been a long and fascinating one, with important breakthroughs shaping the field over the decades. One of the earliest milestones was the creation of the ELIZA chatbot in the 1960s. Although it wasn't autonomous, ELIZA demonstrated the first signs of artificial communication. It could simulate conversations with humans by responding to simple prompts, laying the foundation for future advancements. Fast forward to 2012, and the field saw a revolutionary leap with the ImageNet project. Using machine learning, AI systems were trained to recognize and classify objects in images with incredible accuracy. This achievement showed how AI could handle complex tasks by learning from large datasets, marking a turning point in the development of smarter, more capable systems. In 2016, AlphaGo stunned the world by defeating the world champion of the highly strategic board game Go. Unlike earlier AI, which relied on predefined rules and instructions, AlphaGo used deep learning and reinforcement learning to develop its own strategies. It made moves that surprised even expert players, demonstrating an intuitive understanding of the game. This was a major breakthrough. It showed that AI could learn and adapt without being explicitly programmed for every possible scenario. By 2023, the pace of progress had accelerated dramatically. Advanced models like RStar Math and GPT-4 began to exhibit reasoning and self-correction, going beyond simple problem-solving to improve themselves over time. These systems are learning how to learn, bringing us closer to the idea of artificial superintelligence, a concept that once seemed like pure science fiction, but is now becoming a tangible possibility. Where could AI superintelligence impact society? The potential applications of superintelligent AI are vast, touching nearly every aspect of human life. In healthcare, such systems could analyze massive datasets to discover cures for diseases, design personalized treatments, and even predict epidemics before they occur. Imagine an AI that could eradicate cancer or reverse climate change. These are the kinds of breakthroughs superintelligence could enable. In industries like finance and defense, the implications are equally profound. AI could optimize stock markets, prevent fraud, and design innovative technologies to safeguard national security. But with great power comes great responsibility. Autonomous weapons, for example, could become a double-edged sword, raising ethical concerns about their deployment. Another area of significant impact is employment. While superintelligence could create new industries and roles, it could also disrupt traditional jobs, particularly in fields like manufacturing, logistics, and even creative arts. This raises pressing questions. How can societies adapt to these changes? What policies need to be in place to ensure equitable outcomes? Who are the key players in this race? The progress in artificial intelligence has been shaped by visionary individuals and organizations who paved the way for the technology we see today. Alan Turing, often regarded as the father of modern computing, was among the first to propose that machines could simulate human thinking. His theoretical groundwork in the 20th century, such as the famous Turing test, laid the foundation for what artificial intelligence could achieve. Similarly, John McCarthy, who coined the term artificial intelligence in 1956, imagined a future where machines could perform tasks requiring human-like reasoning, sparking early research into AI. In recent years, prominent researchers like Geoffrey Hinton, Jan LeCun, and Demis Hassabis have driven AI innovation forward. Hinton, often called the godfather of deep learning, has played a key role in the development of neural networks, which are the backbone of many modern AI systems. Hassabis, the co-founder of DeepMind, has led groundbreaking projects like AlphaGo and AlphaZero, which showcase the potential of self-training AI capable of outperforming human experts in complex tasks. Organizations like OpenAI, DeepMind, and Anthropic are leading the charge in advancing AI technology. Their work focuses not only on building powerful AI systems, but also on addressing ethical challenges, such as ensuring AI aligns with human values and remains safe. Philosophers like Nick Bostrom and Stuart Russell have joined the debate, emphasizing the importance of caution and regulation as AI moves closer to becoming a transformative force in society. The emergence of self-training AI marks a pivotal moment in the evolution of technology. From mastering games to solving complex problems, these systems are breaking barriers at an unprecedented pace. While the potential benefits are extraordinary, so too are the challenges. The journey toward artificial superintelligence isn't just about building smarter machines, it's about ensuring they align with the best interests of humanity. What are your thoughts on self-training AI and the future of superintelligence? Are we headed toward a brighter tomorrow or opening a Pandora's box? Share your opinions in the comments, and don't forget to like, subscribe, and hit the bell icon for more insights into the world of AI.
And remember to be uniquely you.